I am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about interrupt structure of 8051 microcontroller. So, before going to see how many types of interrupts are available in 8051 microcontroller, first we need to see what is meant by interrupt and interrupt service routine, and what are the steps that the microcontroller will follow when the interrupt raises. So here, first let us see what is meant by interrupt. So interrupt means the process of interrupting the normal execution of the program to carry out specific task is called as an interrupt. So if any interrupt comes while executing another interrupt is called as nested interrupt. That means here interrupt within interrupt is called as nested interrupt. Now, so here interrupt is an external or internal event that interrupts the microcontroller to inform that a device needs its service. So for example, if any IO device needs service of microcontroller, it is going to send a signal which is called interrupt signal. That interrupt signal may be either external interrupt or internal interrupt. So external interrupt means it will be provided based on the external devices that are connected through the external pins of 8051 microcontroller. It may be INT0 or INT1. And so it may be due to internal event means, so because of some special instructions that we have used in the program. And so here one microcontroller can serve several number of devices. So how it is going to serve several number of devices means, here there are two methods. So one is called polling method and another one is called interrupt method. So these are the two methods that the microcontroller can use to service several devices. Now, so we will see here what is meant by interrupt service routine. So microcontroller can be interrupt in different ways, like it may be interrupted because of some peripheral devices. That means because of some external IO devices connected to this microcontroller, they may produce these interrupts. And another source of interrupt may be some special instructions that we are using while writing the assembly level language programming for 8051 microcontroller. And another way the microcontroller can be interrupted means because of some exemptional conditions. That means due to some internal reasons. So these are all different ways or different sources that the microcontroller can be interrupted. Now, so here we will see first what is meant by interrupt service routine. So, for example, if the microcontroller is executing the main program, if any interrupt comes in between, that particular interrupt breaks the normal sequence of execution of instructions, then it is going to divert the flow of execution to some other program or to the interrupt, which is called as interrupt service routine. Okay. So what the interrupt service routine consists of? The interrupt service routine consists of some simple instructions which consists of a small program by using the instructions, and it is able to perform a specific task. So after executing that particular interrupt service routine, the last instruction of the ISR, that is interrupt service routine program, should be IRET. when that particular interrupt is instruction is executed. Okay, so after executing that particular ISR, and again the control will be transferred back to the main program which it was being executed, and again it starts continuing the main program from where it has executed or from where it has stopped its execution. Okay, so while the microcontroller is executing the program, an interrupt breaks the normal execution of the instructions, then diverts to some other program which is called interrupt service routine. After executing the interrupt service routine, the last instruction should be the return instruction. When that is executed, again the control will be coming back to the main program, and then it continues again executing the main program from where it has stopped. Now, so here, whenever the number of devices interrupts a microcontroller at a time, the microcontroller should be able to handle them properly. Then only we can say that the microcontroller is having multiple interrupt handling capability. That means it has to accept all the interrupts, it has to solve the priorities, and then it should be able to service that particular interrupt which is having the highest priority. Now, so in order to say what is meant by interrupt service routine diagrammatically, so let us assume here first the main program is being returned, and when the microcontroller is executing the main program, and this main program will consist of some set of instructions, like, so it may be consisting of some set of instructions. Okay, and so when the controller is executing all these instructions, if any interrupt comes in between, so this is the interrupt. So if any interrupt comes in between, the microcontroller stops whatever it is doing. So up to here the instructions will be executed. Then if any interrupt comes, it stops whatever it is doing. Then it is going to divert its execution. So it is going to divert its execution in order to execute the interrupt service routine. Okay. So here the interrupt service routine also consists of some set of instructions which is able to perform a specific task. Okay. So while the controller is executing this ISR, the last instruction should be RET instruction, or it should be IRET instruction. And when the last instruction of the ISR executed, again the control will be moving to the main program. Okay. And from the main program, it starts executing the remaining lines of the main program. It continues its execution. Okay. So this is what the microcontroller is going to do when interrupt occurs in between while executing the main program. Now, so for every interrupt, there must be an interrupt service routine. So interrupt is nothing but it consists of some set of instructions which will be performing a specific task. It is a simple program, and that program we will call here as interrupt service routine. Okay. So for every interrupt, there must be interrupt service routine or interrupt handler. So when the interrupt occurs, the microcontroller runs particular interrupt service routine, and for every interrupt there will be a fixed location in the memory which holds the address of the ISR. Okay. So in the interrupt vector table, how many number of interrupts are there? For each interrupt, there will be some fixed address in the memory. And so the group of memory locations that are set aside to hold the address of ISR is called as interrupt vector table. So we will see what is interrupt vector table and how many interrupts are present in the interrupt vector table of 8051 microcontroller, and what is the fixed memory address for each interrupt. Now, so here in this 8051 microcontroller, the data transferring between controller and input-output devices, that is peripheral devices, will be done with the help of two methods. So here what are the two methods means? One is polling method and another one is interrupt method. Now we will see what is the difference between this polling method and interrupt method in terms of data transfer between controller and IO devices. Now, so here first method is polling method. So in this polling method, how the data transfer will be happened. So out of this polling method and interrupt method, so since there is a small drawback in this polling method, interrupt method is preferred. So we will see now what is polling method, then we will understand what is the drawback in that polling method. So in the polling method, the microcontroller continuously monitors the status of the given device. When the device condition is met, then only it is going to perform the service. After that, it moves to monitor the next device until everyone is serviced. That means if there is no interrupt also, in the polling method, the microcontroller will continuously monitor the status of the given device. That means it will continuously check whether the interrupt has occurred or not, though there is no interrupt. So because of this reason, the microcontroller time will be wasted. So it is not going to do any other task during this process. So example, if you see, so one example that we can consider in the polling method is, so it constantly keep on opening the door to check whether anybody has come. Like, so in order to know if anyone has come, first there should be bell ring. But here in the polling method, though there is no bell ring, the person inside the house will be continuously closing and opening the door and checking whether any person has come or not, though there is no bell ring. So he is wasting the time without doing any work, though there is no interrupt. The microcontroller is continuously checking the status of the interrupt. So that is the main drawback in the polling method during data transfer between IO devices and microcontroller. And so here the second method is interrupt method. Now we will see in the interrupt method how the data transfer will be done between IO devices and microcontroller. So in the interrupt method, when any device needs its service, that particular device will notify the microcontroller by sending an interrupt signal. So if interrupt signal comes only, the microcontroller will stop whatever it is doing, then it is going to service that particular device. So the program which is associated with that particular interrupt is called as interrupt service routine. Another name we can also call this interrupt service routine is interrupt handler. Okay. So in this case, the best example we can consider for the interrupt method is, let the bell ring, then the door will be opened to check whether anyone has come. Okay. So if the bell ring only, the person will be going and opening the door. Okay. So when the interrupt comes only, the microcontroller is going to respond to that. Otherwise, the microcontroller will be performing its own task. So this is the main advantage. Here the microcontroller is not wasting the time. So that is why compared to the polling method and interrupt method is preferred for data transfer between IO devices and microcontroller. And now here we will see classification of interrupts. So interrupts are classified into hardware and software interrupts. So here hardware interrupts are also called as external interrupts. So they will be provided or they will be executed because of some external devices that are connected through the INT0 and INT1 pins of this 8051 microcontroller, because those two are the external hardware pins. So if any IO device generates interrupt through the two pins, they are called as external interrupts. And another classification is software interrupts. So here the software interrupts means if you are using any special instructions in the program, they leads to this software interrupts. That is why the software interrupts are called as internal interrupts. And second classification of interrupts are vectored and non-vectored interrupts. So here vectored interrupts means there is not necessary to provide any ISR address. The control will be directly branches to the ISR address and then it is going to execute. But whereas in the non-vectored interrupts, it is necessary to provide the ISR address, then only that particular ISR will be executed in the interrupt vector table. And the third classification of interrupts is called maskable and non-maskable interrupts. So here maskable interrupts means the interrupts that can be disabled, whereas non-maskable interrupts means the interrupts that cannot be disabled. So that means if any interrupt comes, compulsory it should be executed. So these are all different classifications of interrupts. Now, here we will see what are the steps in executing an interrupt. That means when interrupt occurs, how the microcontroller is going to respond. So what is the process the microcontroller will follow when the interrupt occurs? So here are the following steps. Upon activation of the interrupt, that means when the interrupt occurs, the microcontroller will be following all these steps. So the first one is here. When interrupt occurs, it means here microcontroller. So when interrupt occurs, the microcontroller finish executing the present instruction and saves the address of the next instruction on the stack. After saving the address of the next instruction, then only here it also saves the current status of all the interrupts internally, and then it jumps to the fixed location in the memory, which is called as interrupt vector table. So here what the interrupt vector table handles, it holds the address of the ISR. Okay. So the microcontroller gets the address of that particular ISR from the interrupt vector table, and then it is going to jump to it in order to execute. So upon executing that particular interrupt service routine, the last instruction of the ISR program we have to write is RETI, that is written from the interrupt. Whenever this instruction is executed, so that is why the last instruction compulsory in the ISR program we have to write as RETI. When it is executed, the microcontroller will return to the main program where it was interrupted. And so in order to come to the main program where it was interrupted, what it has to do, it has to first get the program counter address from the stack by popping the top 2 bytes of the stack into the PC. So here what is PC means program counter. It is a register which holds the address of the next instruction that is going to be executed. So in order to come to the main program again, it is going to consider this program counter and it is going to take the address from where it has to execute. Then it starts the execution by taking that address. So these are the different steps that the microcontroller will follow when the interrupt occurs. And now we will see what are different interrupts that are present in this 8051 microcontroller. So totally in this 8051 microcontroller, we have 6 interrupts available. Now we will see what are that 6 interrupts. So first interrupt is here reset. Okay, so which you can call as power up reset. And the next interrupts are related to timers. Okay, so 2 timers are related to interrupts. And so 2 interrupts means because here we have 2 timers. One interrupt is related to timer 0, another interrupt is related to timer 1. And next 2 interrupts are related to external interrupts. So here we have 2 pins in the pin diagram of 8051 microcontroller in order to handle external interrupts. So what are that means? INT 0 and INT 1. Okay. So these are the 2 external or hardware interrupt pins. And one interrupt is related to serial communication. Okay. So totally there are 6 interrupts. So this is one interrupt. So here we have 2 interrupts related to timers. So 2 interrupts related to the external interrupts and 1 interrupt related to the serial communication. So all these are the total 6 interrupts that are there in the 8051 microcontroller. Now, so as we have studied, these 6 interrupts will be having its fixed address in the internal memory. So if you see here, the first interrupt is reset. It is having fixed address in the RAM location. Its fixed address is 0000H. And another interrupt is IE0. So as we have seen, 2 interrupts are related to external interrupts. So one is IE0, another one is IE1. So for external hardware interrupt, we have 0003 as the fixed address. And whereas the external hardware interrupt 1, it is also having the fixed address that is 0013H. And 2 interrupts are related to timers. Here the timers related to interrupts are TF0 and TF1. So timer 0 overflow interrupt, it is having fixed address in the RAM that is 000BH. And timer 1 overflow interrupt, it is also having fixed address in the RAM that is 001BH. And next interrupt is only 1 interrupt related to serial communication. So it is having fixed address in the RAM location. It is 0023H. Okay. So all these are the 6 interrupts that are available in the interrupt structure of 8051 microcontroller. And each interrupt is having their own fixed address in the RAM location. Okay. So this is what the interrupt vector table. And so next, coming to the detailed discussion about all that 6 interrupts. The first interrupt is here reset. Okay. So if you see the pin diagram of 8051 microcontroller, 40 pins are there. Among that 40 pins, one of the pin is RST pin. Okay. So in order to reset 8051 microcontroller, we have to provide the positive pulse through this RST pin with the duration of at least 2 machine cycles. So one machine cycle consists of 12 pulses. So since it is taking 2 machine cycles, totally it consists of 24 clock cycles of crystal oscillator. And so after that, that means after providing this positive pulse with the help of 2 machine cycles, next it has to generate internal reset signal. Okay. So if this internal reset signal is generated, it clears all the special function registers, except this SBUF register will not be cleared, and also stack pointer and ports will not be cleared. Okay. So that is what about the reset. Now coming to the next interrupts in the interrupt vector table. Next we have 2 interrupts related to timers, 2 external interrupts, and 1 interrupt related to serial port. Okay. And here are the different interrupt registers. So in order to configure that particular two interrupts, we have here two important interrupt registers. One is IE register, that is interrupt enable register, which is used to enable the particular interrupt. And another register is IP register, which is called interrupt priority register. So that particular register is used to set the priorities of the interrupts. Here, if you see this interrupt enable register, you can represent it as IE register. And another one is here IP register, interrupt priority register. Now we will discuss about these two registers in detail. First, coming to the interrupt enable register, it is an 8-bit register. So by using this 8-bit register, the interrupts can be enabled by software in order for the microcontroller to respond to the interrupt. So in order to do that, we are going to use this interrupt enable register. So this interrupt enable register is used for enabling and disabling the interrupts. So enabling and disabling means you have to unmask that particular register bit, and disabling means disabling of the interrupt is done with the help of masking that particular bit in the register. And so here we can see this is the 8-bit register format of interrupt enable register. So here it consists of totally 8 bits starting from D0 to D7. So this particular register is used to enable and disable the interrupts. So here you can see this is here EX0 and EX1. These two interrupts are related for external interrupts. And this is ET0 and ET1. These two interrupts related to timer 0 and timer 1. And here this is ES. This interrupt is related to the serial port. And this is EA, which is the interrupt related for acknowledgement. Okay. So now we will see about all these 8 bits, what happens when that particular bit is enabled and disabled. So coming to the 8 bits that are present in the interrupt enable register. So here the D7 bit is, this is IE represents interrupt enable. Here 7 represents the 7th bit of that particular interrupt enable register. So EA is the bit which represents acknowledgement. If that particular EA bit is 0, interrupt will not be acknowledged. If EA is equal to 1, interrupt will be enabled. And the next 2 bits in the interrupt enable register, that is 5th and 6th bit, they are reserved for future use. And 4th bit is ES. This bit is used to enable and disable the serial port interrupt. So for example, if this ES bit is 1, it is going to enable the serial port operation. And if it is 0, it is going to disable the serial port operation. Next bit is ET1. So T1 represents it is timer 1. So that particular interrupt may be enabled and disabled whenever the timer 1 overflow interrupt arises. So that particular bit will be 1 when timer 1 overflow interrupt enable, and otherwise if it is disabled, that bit will become 0. And next bit is EX1. So it is related to the external interrupt. So that particular bit, if it is that bit is 1, it is going to enable the external interrupt 1. If it is 0, it is going to disable the external interrupt 1. Next bit is ET0. That particular bit is enable or disable timer 0 overflow interrupt. And the last bit is EX0. That bit is used to enable and disable the external interrupt 0. So if EX0 is 1, it is going to enable the external interrupt 0. If this EX0 is 0, it is going to disable the external interrupt 0. So this is what about one of the register, that is interrupt enable register. And another interrupt register is interrupt priority register. So this register is used to assign the priorities for the interrupts. Okay. So when we can alter the sequence of interrupt priority by assigning the higher priority to any of the interrupt by programming a register called interrupt priority register. Now, so to give the higher priority to any of the interrupt, we have to use or modify the bit that is present in the interrupt priority register format. Now, so this is the interrupt priority register format. It consists of totally 8 bits. Here we can see D0 to D7. Okay. So this PX0 and PX1, these two are the priority bits related to external interrupts. This is PT0 and PT1, which is used to set the priority for the timer interrupts. This is for timer 0 and this is for timer 1. This PS bit is used to set the priority for the serial port, and this is the PT2, that is the priority used for setting the PT2 bit. So if we want to set the highest priority for any of these bits, that particular bit should be made as 1. Then the highest priority for that particular interrupt will be set. So if we want to assign any low priority for any of the interrupt, we have to assign that particular bit as 0. Then the low priority will be allocated for that particular interrupt. Now, so here are all the 8 bits that are present in this interrupt priority register. So here the first 2 bits, that is 7th bit and 6th bit of the interrupt priority register, they are not defined. They are reserved for future use. So if you see here PT2, it is the priority bit related to timer 2. So it defines the timer 2 interrupt priority level. So if that bit is 1, highest priority will be allocated for timer 2. If it is 0, lowest priority will be allocated. So here PS means that particular bit is used to define the serial port interrupt priority level. So for all these, the first letter P represents used to set the priority, and the second word says the type of the interrupt. So this is PX1. So it defines the external interrupt 1 priority level. For PT0, it is going to define timer 0 interrupt priority level, and PX0, it defines the external interrupt 0 priority level. Okay. Now, so interrupt priority, how to set the interrupt priority if number of interrupts are having the same priority level. If different interrupts have the same priority level, it is going to follow the sequence of priority by interrupt priority after reset. So as per 8051 interrupt priorities, the lowest priority interrupt are to be served until the microcontroller finishes with the highest priority ones. That means if the microcontroller is executing the lowest priority interrupt, if any other interrupt comes which is having the highest priority, the microcontroller stops serving the lowest priority interrupt and it starts servicing the highest priority interrupt. Now, so these are different interrupt priorities that are being allocated in 8051 microcontroller. So as we know here, it is having totally 6 interrupts. So irrespective of the reset interrupt. So if you see IE0, which is called external INT0 interrupt, that particular interrupt is having the highest priority. Next highest priority will be for this TF0, next for IE1, next highest priority for TF1 interrupt. And the lowest priority will be for RI and TI, that is receiver interrupt and transmitter interrupt related to the serial port operation. That will be having the least priority. Now, so coming to here the external interrupt. So in order to handle external interrupts for 8051 microcontroller, we have 2 pins. One is INT0, another one is INT1. So these interrupts can be programmed either in the form of edge triggered or it may be level triggered. So if we consider here the clock cycle, okay, so here this is the positive edge and this is the negative edge. So interrupt may occur during that duration, or this is the level edge, positive level, and this is the negative level. So the TCON register will be used to program external interrupts to edge triggered level or level triggered form. So the TCON register is called as a timer control register. It is an 8-bit register. So TCON register is having fixed address in the internal SFR address space, and it is 88H. So fixed address for TCON register is 88H. And all these are the 8 bits that are present in the TCON register. So here TCON is an 8-bit register. Now, so here you can see, in order to handle external interrupts means, so this is IE0 and this is IE1 related to external interrupts, IT1 and IT0 related to timers, and this is TR0 and TR1 related to the serial port, and another 2 bits are TF0 and TF1. So here this is IT0. When that bit is set, the interrupt will be negative edge triggered input. If it is 0, it will be low level triggered input. If it is IT1, if that IT1 bit is set, if it is high, it acts as negative edge triggered input. If that particular value is, that is IT1 value is low, it acts as active low level triggered input. And another interrupt is IE0 and IE1. These two interrupts are external interrupts. If this IE0 bit value is 1, it will be 1 only when this INT0 is activated as level triggered, and it will be 0 when INT0 is activated as edge triggered. And another bit is here TR0 and TR1. So here this is related to timer 0 and timer 1. When this TR0 bit is 1, it is going to set timer 0 in the run mode. If the TR0 bit is 0, it is going to set timer 0 in the stop mode. Coming to this TR1 bit, if that particular bit is set, or if the TR1 is equal to 1, it is going to set timer 1 in the run mode. If the TR1 is 0, it is going to set timer 1 in the stop mode. Next bit is TF0. If the TF0 bit is 1, when the T0 overflow occurs, that means timer 0 overflow occurs. And TF0 bit will be 0 after resetting the timer 0. This will be changed to the 0 state. And coming to the TF1 bit, it is similar to the TF0 bit, but it is related to timer 1. Now, coming to the serial port interrupt, it is the interrupt used for transmission mode or reception mode. So, if it is a transmission mode, the type of interrupt will be TI, transmitter interrupt. If it is provided in the reception mode, the type of interrupt will be RI, that is receiver mode. So, here there are 2 bits of SCON register. So, here SCON register says serial control register. So, it is also an 8-bit register which is having fixed address in the SFR address space. And it is a 8-bit register, and that particular register is bit addressable special function register. And so this SCON register is having fixed address in the SFR address space, that is RAM location. So its fixed address is 98H. So this is the 8-bit format of SCON register. So if you see here, this is 98, 99, 9A. Okay. So all these are the fixed addresses for this particular each bit. So each bit of SCON register is bit addressable. That means each bit is having its fixed address in the SFR address space. So it is an 8-bit register. Now we will see here what are different 8 bits that are present. So mainly this TI and RI, these are the two interrupt bits which are used to provide interrupts during serial communication. So here are the 8 bits related to that serial port. So using these first 3 signals, the mode of serial port operation can be set. Okay. So this SM0 bit determines the serial port which will be operating in mode 0 and it will be acting as a shift register. And this SM1 bit says this is a serial port related to mode 1. Okay. And this is SM2 which is used to enable the multiprocessor communication both in mode 2 or 3. And the next bit of SCON register is REN. So using this REN bit, setting or resetting of the software can be enabled or disabled, but it is only for reception. And next bit is TB8. Okay. So it indicates 9th bit that will be transmitted in mode 2 or 3. So it can be set or reset by the software. And next bit is RB8. So R here represents receive. So in mode 2 or 3, the 9th bit was received in mode 1. Okay. So based on all these bits enabling, this particular description will be followed. And the next bit is TI. So TI represents transmitter interrupt. Okay. So the transmitter interrupt flag will be set only when all the data that is being present at the transmitter after transmitted. Okay. And so this bit is set by the hardware. And the last bit is RI, which indicates receiver interrupt. That is the interrupt flag related to the receiver part. So it can be set by the hardware, but it should be reset by the software. So this RI is the interrupt that will be executed during the receiver section. So after receiving all the complete data by the receiver, then only this RI bit will be set. So this is what about interrupts of 8051 microcontroller. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.